Welcome to the cross-site scripting lab. So, as usual guys, we're gonna have multiple exercises here so that you can fully understand this specific vulnerability. Just a quick reminder, since you already attend our slides class with all the details about this vulnerability. So, cross-site scripting, also called XSS, it is a web-based attack, okay? And it is called client-side attack. Why? Because it is executed in the browser. That means it is not affecting the web server. Every time you hear about a cross-site scripting vulnerability found in, let's say, WordPress software, that means that something happens in the browser while visiting WordPress. That doesn't mean that someone compromised the web server. Now, there are two types of cross-site scripting. One is called reflected cross-site scripting or non-persistent, and the second one is called stored cross-site scripting. Simple explanation: stored cross-site scripting means anything that the attacker is sending, obviously malicious, is going to be stored normally into the database web server. And that means that every time the end users visit that specific section, the malicious content is going to be loaded. It doesn't matter if you are connected and then you log off of the application. Since it is already in the database, it's going to be loaded every time you visit it. Obviously, this is the most dangerous scenario for a cross-site scripting vulnerability. The second option is reflected. Reflected means that the attacker must put malicious information into the URL, and only the persons clicking exactly the same URL with that malicious content will be affected. What are the consequences of cross-site scripting? Well, basically, the attacker can execute JavaScript, Visual Script, or HTML, which are usually the most common languages being executed in the browsers, and they can redirect your browser to their own website so that they can infect your machine, well, try to infect your machine. They can also steal your cookies so that they can connect to your bank or any other application that you are using locally in your machine, so they can impersonate legit users. They can also load phishing websites by adding their own HTML code. And just so that you know, we have a pretty cool demo about cross-site scripting, a real-world vulnerability in a WordPress plugin. Check it out in our case studies so that you can see from a penetration testing point of view what you can do. Okay, so back to our lab. We're going to be talking about the process as a security code reviewers, how we can hunt and find these vulnerabilities in the source code manually. We can also use scans, and that's going to be another lab, but it's very important for you guys to understand how to find these bugs just by looking through the source code. Then we're going to talk about how we can verify that the bug is real, gather all the evidence, and finally prepare the report to be presented to the stakeholders, business owners and developers. So let's start with our first example. We have the path in our lab, which is under the web server, which is commonly found in Kali. This is a Kali system, normally used for penetration testers, pretty useful. And we are in the path /var/www/CSTT, which is our academy name, cybersecurity think tank, and the folder XSS. XSS is also an abbreviation of cross-site scripting. So let's open our first exercise. In this first exercise, as usual, we need to identify the entry points. You remember the threat modeling class. We need to find all the entry points which can affect the behavior of our application. We can see here that there is a parameter called data being received via get parameter in the query string. We'll see that in the browser. And that parameter is going to be copied inside a JavaScript block into an A variable, and then that variable is going to be pasted into an HTML element called text area. As you can see, the input received is being copied into the HTML response. Cross-site scripting is executed in the browser. When you see input being pasted back into the HTML code being sent to the browser, that's a clue for a cross-site scripting related issue. Since here we don't have any input validation, because we can see the input is in get data and we don't see any filter, that's a red flag for us as a security code reviewer that there might be a cross-site scripting problem. As usual, now that we understood the source code, we need to replicate and to run this script so that we can have a better understanding. We are using PHP here, but the same concepts are applicable to other languages. So we pass the the question mark signed so that we can pass a parameter. In this case is the data get parameter and the value, the content. Every time you pass a get parameter must be after the URL, as you can see here. So we hit enter and we can see that, as expected, the input that we enter is being copied back into the response into our text area element. We can, change it to any other value. So this is the normal behavior, and then we can see that, as we saw in the source code, there is no input validation, and then we mark down this specific script as a potential cross-site scripting. Let's move to the next exercise. So we go to this option 2, which is called normalizer. Again, we can see that it receives a data argument, but now via post request. Post request is a different HTTP request that it is sent normally through forms, HTML forms. But we can see here that the content of that entry point is being sent through something, which I can tell you right away it is an input validation, and eventually the content received is going to be changed into something more secure. That means we have a filter. Keep in mind that you don't need to know all those functions. Every time you find a function in the code review, it's always recommended to go and understand exactly what that function is doing. Here we can see that all the content received is going to be filtered out. And let's go quickly to this specific function. This function, as we can see here, is going to transform all the input into these specific values. If it receives an ampersand, it's going to be changed into the HTML entity. It is called HTML entity, which basically is the same representation of that specific value, but without being treated as an HTML code or JavaScript code, because it's dangerous. Okay, they can also use double quotes. If we found double quotes, they change it to the HTML representation, HTML entity, the same for single quotes, less than and greater than. So those are the most common characters being used by attackers when trying to execute cross-site scripting attacks. So that's the main reason that this specific function, it is filtering them in order to change their context, and they can be transformed into something that cannot be executed. And there are a couple of options. We can see that we saw in our source code some specific options, which is this end quotes. That's very important to be set, because that's gonna also include the single quote and double quote conversion. If you don't put that flag, that means it won't protect against attackers sending single quotes or double quotes chars, which can be used for cross-site scripting. So those are the basics of this function. Then we can see that there is something called normalize. That's something that, let's assume at this point that we don't know what it is. We have multiple lines of code to analyze, so we need to move fast. We need to mark down the potential vulnerabilities, and then in the next phase we will validate them. So here we can see that it is some kind of input validation. So we are going to run this specific script and see how that works. So we run normalizer, and this is I forgot to mention that, guys, sorry, it is in the source code, but we can see it here. It is a typical scenario where it is a search value that you have a box, and whatever you enter to search, it's gonna receive the response saying, oh, the search for, in this case, Danux has been found n times. In cross-site scripting, since we know that it is going to be affected the browser, we need to concentrate our efforts into find sections in the application where the input sent is pasted back in the response. The best known scenarios are search engines, as we can see here, and contact forms. You remember when you are filling out a contact form and you are ready to submit it and you miss to put the right phone number? After you click submit, what's gonna happen? It's gonna put an error message saying, hey, the phone number is not in the proper format. But that means that well, it depends on the application, but most of the applications send the request to the server and come back saying, hey, you know what, this is not a valid phone number, or this is not a valid credit card, or those kind of things. But the content that you filled out in the form was sent and received and pasted back into the response. That means the attacker can say, oh, whatever I sent is received again, then I'm going to start injecting malicious JavaScript or HTML. So that's very important when hunting cross-site scripting, to look for places where our input is pasted back in the response. So in this scenario, if we can try to put malicious information, in order for us to send post request, since the post cannot be sent here, as we saw with the get request, the get request variables can be sent here as part of the URL, but the post request needs to be sent in a different way. We need to use something called a proxy. We have multiple proxies, but here with this browser, which is Firefox, we can use a really cool plugin which is called Temper Data. Temper Data, you can just search for it in Google, you will find it. Temper Data can allow us to intercept packages on the fly. So we set start tamper, and then we click here on submit, click tamper, and you can see that the data input field, we can put something different. Obviously in this case, since we are not using this maliciously, it is exactly the same that if we put something here like something like that. We stop the tamper. We can see that the response was sent back. This feature is important for us in the verification phase, but right now we are not injecting anything malicious. So you can see here that if we inject a single quote, let's say, because we are going to try to find vulnerabilities, if we click, we can see that the representation is exactly as expected, the anux and a single quote. But if we look at the source code, we can see here that we have this value normalized. Let me check it quickly. Yeah, okay, so then we can see that if we inject something like this and we go to the source code, we can see that the source code, there is a less than. That means our less than sign was changed to what we call the HTML entity, which means visually is going to be presented, but behind the scenes is not going to be put as a less than, because can be used, as you can see, HTML use the less sign as part of its code of execution. So this is saying I'm not treating it as a part of HTML code, because you can use it maliciously. Let me try another check here, and you can see that I don't know why, for some reason in the previous example the single quote was not transformed, but well, here it's been transformed. Also the single quote has been transformed to the HTML entity representation. Again, you can see it here visually is the same, but behind the scenes is different. Let's try obviously other characters like quotes that we know is going to be filtered out, and the ampersand. We click on it. Again, the visual representation is the same, but behind the scenes it is transforming everything so that it cannot be treated as HTML code in this case. Okay, so in this scenario we can see that looks like there is a proper validation of the input received, so that we cannot inject malicious things. But let's assume, as I said, that we don't know anything about this function. What we can see here is that just after copying the response back to the browser right here, there is some processing here that we don't know what it is. Ideally, you should put the output validation right after copying the content back to the browser. But here it looks like there is a process in the middle that probably might change the content and could be exploited by an attacker. That means we cannot say here that this is safe from cross-site scripting. We just mark it down for us to verify it manually in the next phase.